what are we going to talk about?
Something
Microservice versus monoliths, or monoliths versus microservices. Yeah.
exactly. The epic battle between
I
the two services.
I literally wrote a whole page full of ideas that I had. Not sure if I will use them, but it's such a hot topic. So
We can write books about them. But
yeah,
the thing is, in my opinion, at least, it's cooled down a bit because if you saw like 5 years ago or something like that, people were like super straight into it has to be microservices because Netflix is doing it. While yeah, you weren't the Netflix yet. Like, yeah,
uh,
we don't want to make the mistakes that they made in the beginning and stuff like that. And then you're like, yeah, you're just over complexifying, if that even is a word, before you even get started. Like, great infrastructure, no product. Yeah, didn't succeed. So, in that sense,
you want to do an introduction?
yeah, sure.
I also hope that
Yeah,
my FPS is going to be more now. My
yeah,
camera
for sure.
FPS now that I have my new laptop because the previous video was not very good.
Yeah, and also we have
Was
to
very
do another setup.
low FPS. Yeah,
We
yeah.
have
Otherwise, it's going to be
a
an
rig with
investment.
a Elgato capture card, and then
Yeah, I also checked like on Reddit how much
yeah,
money you can make with a podcast, and people said, well, you actually only lose money with the podcast.
yeah,
So indeed, if you have to keep
statistically
buying,
-1,000.
if you have to keep on buying new equipment, then you're gonna lose a lot of money.
Yeah, definitely, definitely. But we can use it for other stuff as well. So no, without further ado, let's get started with the intro. Hi, everybody. Um, my name is Jorn Chambers. I'm the co-founder of Infra IT. We've been working in DevOps for over like 15 years now, I think, something around that. We are going to talk about microservices versus monoliths. I'm going to let Edward do his introduction as well.
Yeah. So my name is Edward. Also, have been working quite a long time in DevOps now. DevOps and cloud, mainly with AWS. Mm. Since 2014, something like that. And yeah, so today's episode is about monoliths versus microservices. And I think in 2014 was really the first discussions that I had about splitting up repos and stuff. So yeah,
Yeah,
10 years ago now.
yeah, exactly. I might have overestimated my first experience level. At least it feels like 15 years. Let me put it that way.
It's because we did system administration before that as well.
Yeah,
So
true, true, true.
um,
Like DevOps
which is
was
already
writing
close to
shell scripts.
DevOps. Writing shell scripts, yeah.
Exactly, it's the first form of automations. Yeah, yeah, exactly. And Perl, a lot of Perl as well. Well,
Puppet was already there for a long time as well.
yeah, 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 but not in
Uh,
the like in the enterprise. It was like,
yeah, I think like when we worked together the first time, I think there was another company that was already using Puppet to
oh yeah,
provision
yeah, definitely, definitely,
service.
yeah, 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 definitely.
And then we took that over and it was like, oh yeah, Puppet, yeah.
Exactly,
Yeah.
exactly. Oh, that has been a long time.
We removed it from our memory.
Yeah, you can see,
That
I can
part.
also see it in my hair.
You,
It's
you
turning
know
gray.
when you went to a customer and then you kind of open the door and they say, this is the server room. These are the
Yeah,
boxes.
yeah. Luckily, we don't have to do that anymore. In that sense. No, awesome. Yeah, let's dive right into it. I think the monolith versus microservices. So maybe we can go into the advantage of everything and what our experiences are, what we've seen
Yeah,
in the
yeah.
past, something like that in that
So
format.
I can start with the end. Microservices are probably not a good fit for most people,
Yeah,
I
exactly.
think. Uh, and just saying that is already controversial because people are like, no, you should first, you have a new project, you should think about what the design, what the architecture is going to be, and then the best technology kind of wins, and that's the technology that you're going to use, and that could be microservices.
Yeah, like
Go
if
ahead.
you're starting to design an application, there's no traffic yet. Um, how do you know what parts are going to be used a lot? What parts need to be scaled? Like if you see like the another like better approach, in my opinion, is to see what parts of the application need scaling or are like change frequently or whatever. like move those out of the monolith and start, if you want to do it at least. But for the ease of development, especially in the first couple of years, just yeah, exactly. Stick with a monolith.
Ease of development is a big one for me. I had a discussion with someone in 2014, and we were going to work on a project. Um, there was already some work done on the project, and we kind of both joined the project at the same time. And the first thing he wanted to do is he said, we need to redesign the way that our application is structured. We need to create a Git repository for every library that we have.
Oh
And
yeah.
actually, we had a long discussion about it because I said, like, if I make a change, I don't want to make a change in different Git repositories. I don't want to do like 5 Git commits just to make one change, do one PR. And he said, no, 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 we need to separate it, and this is going to be certain domain knowledge here and knowledge here, and then we can work on this separately, and then it's going to be much better. And I remember even then the discussion was already like, yeah, like it was already a very heavy discussion. He was very, very opinionated about it. And in the end, I kind of just gave up on the discussion. I was like, okay, if this is the way you want to do it, I'm not that opinionated. If this is the way you did it in a previous company and it worked, let's do it. Uh, and I see that often coming back, like someone that's very opinionated about doing it a certain way kind of wins the discussion because other people just give up. Uh,
Just don't care. Like as long as the job gets done, whatever.
Yeah, yeah, because people are like, indeed, the job needs to get done. I'm not going to discuss this for 2 weeks. Let's just get started. Your way, okay. And then you already make it yourself so much more difficult, I find, having like 10 repos instead of one. Because then they have, yeah, everything is already kind of distributed across multiple code bases. And
Oh
then
yeah.
it's already getting more difficult to maintain. And I think that's something that always comes back. Like, what's the maintainability? Like, how long does it now take to make one change?
How
And
big is the
in the
team?
and how big is a team? Yeah.
Yeah.
And in the beginning, if you're doing MVP or even after MVP, you have a very small team. You all work at the same code base. Um, Git was invented to work on the same code base. You don't need to separate it. So that's already like the first mistake that I find. Like, well, Git is there to resolve the conflicts. You don't have
Mhm.
to try to avoid code conflicts. Git is there to help you with doing the merge.
Yeah, definitely.
Um,
But it's not only that. Like what I see a lot as well is when they start like or when they are heavy opinionated about that, they also are blindsided sometimes by it, and then they're like, yeah, but they forget, for example, the part that it needs to be loosely coupled, for example. So basically, they split everything up in separate API endpoints, whatever, in separate microservices, and then all of a sudden something breaks, but the whole application is down. And then it's like, yeah, it just created like a distributed monolith because it's just separate services. And then you introduce just the operational risk alone. Like while you have an application monolith that runs 2 times, like redundantly with a database period, but then you have like 5 services that run multiple times to be redundant in like 5 separate databases because we separate the data in other databases as well. And then you have a maintenance window on one database server or whatever, and then it brings the whole application down because it wasn't that loosely coupled or whatever. And then they still forgot to bound the context of every application into one service that it can logically operate. Let's say some good example. Let's say you have an application that sends an email. It doesn't need to be synchronous. The application doesn't need to wait for it. You can let the application push it to a queue and then read it from the queue and send the email. But the application doesn't need to wait for the feedback of the SMTP server. Like that's a small bounded context that can do that. But I've seen applications being designed that you have like how much was it, 5, 6 services, but they all had to be running the same version. Like very important. They were super easy, super hard to debug. It was like local development was a nightmare. The setup around that, because it was like basically a distributed monolith. And yeah, that's that
I
was no
think
fun.
I think you already touched on a lot of different points actually. Like um, the first one, that if one component goes down, actually the whole application goes down. That's a quite interesting one because you have indeed the circuit breaker design pattern.
Yeah.
So and Netflix has a great example of that, right? So if, let's say, the recommendation engine fails, then they just show you
Yeah.
the standard
You can still
videos that you
watch
can watch.
shows.
You can still watch, yeah. But it's so hard to implement, and it works very well in their use case. Actually, Netflix
Yeah.
is a very simple app. It's just like one app. But then when you have like an enterprise application and you say, okay, if this component fails, the whole application still needs to work. That's actually quite some effort that you need to put in there if you want to achieve that. And what indeed happens is then you can start building your microservices, but you don't have the time to then say, okay, every component can independently fail because you're
Yep.
still in let's say one team. Even if you are 5 or 10 developers, you're still one team. Um, and then indeed, like you say, everything needs to run on the same version. And that's what I find very interesting is that they will always say, or like not they, but when you have a discussion with someone, they say like, yeah, but Facebook, Amazon, Netflix, they're all using microservices and they have great results with it. But then if you actually are going to see how they implement it, for example, Amazon, um, one team will maintain one microservice. So if you are one team and you have one app, well, that's your monolith, right?
Yeah.
And then within the whole organization, if you have multiple teams, you can then indeed have multiple monoliths that then indeed together become a microservice.
Yeah.
And then you have a contract between two teams, and your contract is the API. And then you expose the API to another team, and then you say, okay, on V1, we have these endpoints, and on V2, we'll have these endpoints, and then V2 is not compatible with V1. But if you're still within one team, what often happens is that you indeed need to be on the same version. Your
Yep.
contract is actually not really a contract between different teams, but between one team, between sometimes yourself. And then you end up like making all these changes in your microservices, and then you have to deploy it as one because your changes can only work together. So it defeats the whole purpose
Oh yeah.
of having microservices. And that is what I find that adds a lot of work. If this one person to do this one PR, right, to make this one change, has to go to different Git repositories, make changes, test these changes between those two services or three services, and then need to make sure that these three services get deployed at the same time, otherwise it will break. That is what I find a lot of where time is wasted.
Oh yeah.
So it makes sense if you're in a big organization and you are just kind of have your one microservice or one monolith. You deploy that has an API. You just maintain that. You have the contract. You if you want to change something, okay, it will take longer because then you might have to communicate with teams or you might have to write documentation. There's going to be a new version. But if you're just working within one application, you just want to get the change out very quickly, and you
Yeah.
don't want to have your architecture preventing you from doing something very very fast.
No, no. Also, like um, I always look at like because I was comes from the jobs that I previously did, and I always look at it from an operational perspective.
Yes.
Not only developers but also operational, and then you see when were the times that yeah, shit gone really, really bad, basically. And it was always like in such cases where like you said, the contracts were not explicit contract or implicit contracts. People made assumptions. Like the organization was basically not ready to go to microservices yet. But either way, they just yeah, they did. You see the big companies do it, and you think like, ah, if they do it, they have such a small engineering, they have such a smart engineering team. They do go to do presentations on YouTube and stuff like that. And it's all super interesting. But they, what people don't tend to see is that the road that they had to take to get from point A to when they started to point B, and even if it was messy in the beginning, they managed to get to the scale of like what they're actually now, and they're actually solving problems. But like it's that over eagerness to do it right from the start that sometimes like
Yes.
prevent from getting something actually out, which is the important thing.
Yeah.
I don't care
Yeah.
if I'm watching Netflix if if it's a monolith, or LinkedIn, for example, they're not split to microservices since quite some time, like a couple of years now only.
Yeah,
And
they
before
started
that,
with monoliths.
it was
Mhm.
just one big monolith. I don't say it was the best scenario for them, but it kind of works, right? People find jobs and stuff like that. Can post recommendations and whatever things on LinkedIn that people post, but yeah, it doesn't really matter if you can ship, but and
That's the
whenever,
most important, I find, the
yeah,
shipping. Like the question should not be what is our ideal architecture on a
no,
technical level. The question should be there's a business need to create this application and we need to deliver features. What is the quickest way right now
yeah,
to deliver as many features in the next year or next 2 years? And then when we have our next round of funding, because we scaled, now we have 10 times, 100 times the users,
yeah,
then we can always re-architect. But now we are just kind of working towards a certain milestone. Like maybe companies should communicate like, okay, we actually have only 1 year of money, so make sure that it only you only design up to the 1 year of money that we have, and then we have new
yeah,
funding, and then we can re-platform if necessary, because then we'll have a new round, investment round. But initially, we like
yeah,
you should have a platform, an app that you can just deliver features.
yeah,
And that's how LinkedIn became big, and that's how all these Instagram
yeah,
and all the other companies initially became big, because they just kind of brought something out, more features, and then suddenly they got picked up. And then later on, indeed, when you have more developers, when you have a bigger team, when you have the capital, right, when you have the money
yeah,
to spend weeks thinking about something, then you can make these changes. But in the beginning, you don't have this time, and then a lot of companies will never have the scale. Like almost everyone, all the companies we work with will never have the scale of these big enterprises, right? So
exactly.
uh,
Because they're also not targeting those. They're not a B2C product, for example, to serve videos or whatever. Like the use cases, like if 100,000 people on Earth can become a client, yeah, like it's hard to like there is no scaling issue, right? Like you just create a monolith and scale vertically or horizontally with that monolith, so as long as you can, while just delivering features and services that your clients ask for. And if the time and when the time comes that you need to scale to like a really really big number, obviously that's also a luxury problem, because that means that you have so many clients that you can also pay for it to re-platform it
exactly,
and
you will
expand the
have the
team.
money.
And
Yeah,
obviously
yeah,
that
yeah,
doesn't
yeah.
mean like to be just I'm just gonna boot an Ubuntu in whatever cloud vendor that I'm using. I SSH into it, I install Apache on it, and go. That also doesn't mean that. Like there's still some like best practices in between that operationally.
You could
So
make an MVP. You could make an MVP like that. I
true,
think you
true,
could
yeah,
say,
yeah,
"This is my demo environment. I just spin up a server. I put my app on there." But then, indeed, once you want to go to production, like you want to have real clients on there.
yeah,
Nowadays, what do? You build a Docker container. You push it to one of the container frameworks on the cloud. They put a load balancer in front of it. Like often, this is done automatically with the products that Amazon, Azure, and Google Cloud have. Everything is kind of done for you if you
yeah,
use these products, and then you just have your application, your backend, maybe with a front end, or your front end you just kind of put on object storage, because that's just static data. And then you can still scale that. So if
hmm,
you now have one user, okay, you have one instance, but indeed, like a monolith doesn't mean that you cannot scale it. So you can still run 10 instances of those. Okay, you will need a bit more memory
yeah,
than a small component, but like you said in the beginning, you don't know what component will get most traffic. So it's the easiest way is to just scale your backend 5 or
yeah,
10 times, depending on how much is necessary. And that is actually so much easier. Like you say, if you look from an operational standpoint, so you can look at it from the developer, and can look at it from operations. But I think starting with a monolith, both
yeah,
developers and operations benefit. Because if you start and building new services from the operations view, well, now you have to write all this code to to provision new services, even though it's within the same cluster, if it's Kubernetes or ECS or some other container service, you still need to spend time spinning up these services and then, okay, how much memory should we put in that service? Okay, what environment variables should we expose? What should be the access that it has? What access does it have to other cloud services? Like these are all things you have to think about. And if
Yeah,
you just have
absolutely.
one backend, one application that runs, you don't really have to think about it. How much memory? Well, enough memory so it can run, right?
Yeah,
Um, and then how many databases? Just one database. Unless you need another technology, but in general, okay, you start with one relational database. And then okay, what environment variables should I expose? Well, you just have one list. You don't have multiple lists, so that's already easier. And what access should I have to the different cloud services? Okay, yeah, well, just the ones that we use.
yeah,
So it
absolutely,
just
absolutely.
it becomes so much easier. And then indeed, if you then say, okay, we want to run microservices, but we just gonna push all these environment variables. We're gonna give access everywhere. Yeah, then you kind of, like I say, you're running a distributed monolith. Then it's not a real microservice anymore. Um, then it just kind of, for the sake of saying I run microservices.
Yeah, exactly.
Uh, yeah,
To
because
be
indeed
able.
you can run all these small compute uh, services connected to the same database and kind of have everything the same in them, like environment variables, access rights. But what is the point then, right? Splitting the code. Every programming language, and now we're going back to the developer point of view. Every programming language has modules, has libraries, has packages,
Yeah,
and those things were
definitely.
made to separate the code. So you don't really need to separate it between different code bases. You just have one repository um, with those packages, and then you work on it all together, and you merge enough to your master, your main branch, and then when there's conflicts, you deal with the conflicts, and then you try to release as much as you can.
Yeah, absolutely, absolutely. And like like also if you now look at like whenever a company comes to us and they say like, hey, we're starting an MVP, we don't want to start too small, and I mean with that something like Heroku or whatever, something like that. We just want to have a um, to be able to run containers and stuff like that. It takes like, because obviously because we have everything prepared, it takes us 3 to 5 days to build up an infrastructure that is relatively hands-off, where developers just push their code and it gets deployed on whatever cloud provider they're using, um, like automated pipelines, all that stuff, and you just see like what a big success that is in comparison to over engineering everything from the beginning, to just be able to, like in Amazon example, ECS Fargate, for example, you just let the container be built, push it to there, and just run it, easy peasy. And they're done. Their infrastructure can scale as much as they want. They don't have that of operational overhead. But then there are obviously others, like you said, that want to yeah, over engineer it from the beginning, because obviously ambition is healthy and is good, that you think you're going to be able to need it, but in the end, like um, things like the application itself doesn't become like the microservice, like I said in the beginning, like are not self-contained anymore. The latency is going to get higher in my microservice as well. gRPC kind of like or compression, whatever, so kind of can solve it there, but it all becomes more sluggish, and especially like the deployment. That's something I keep, like, as soon as everything runs and everything works, that's awesome, but when something goes wrong, it goes wrong really badly, and then it becomes like a trail to find where the hell is the issue existing, and then you have to go through logs of 5 services, and then the application is down, clients are unhappy, and yeah, what did you achieve there?
Microservices, microservices increase the scope of the infrastructure.
Yeah.
So it's not just something went wrong with the application, so we go into the application, we try to figure out what went wrong. No, it
No,
can
no.
be on a network level.
Yeah.
communication between services. Maybe someone deployed one service and while it was deploying, something happened, and then request went wrong because how they switch, or there's so much more scope. And that is actually the problem because in the beginning, not even in the beginning, like when you run a simple application, do you indeed want to spend time on all this? Do you want to spend time on debugging all these complex distributed computing problems? Because now your system
Hmm.
became a distributed compute. Um, you're
But
doing
it's
this distributed computing, and with all the extra problems that you can have with that.
and also there's not only an operation like a cost involved around the person actually developing it or debugging or administrating it, like the cloud engineer itself, which is a role that in most companies that you see that come to us don't necessarily need from the start after the initial setup has been done, but like the cost of the tooling, like if you have, okay, yeah, you obviously have cloud providers, their own logging solutions and stuff like that. But we all know how they kind of function. That's why Datadog or New Relic and those types of tools make so much money, because they figure out a way of to easily create a dashboard and you can easily find everything that what is going on in the application. But even then, like if you look at some of our clients' bills on Datadog, for example, just it's logging, right? And it costs like thousands and thousands every month just to be able to have a look at what is possibly going wrong. It's quite obscene,
And
right?
there's no business benefit in
No.
having Datadog because it's nicer to log. It's
Yeah.
just a benefit for the engineering. And that's kind of the problem with all this over engineering that happens is that, like, okay, what is the benefit now for the customer? Is there a benefit for the customer? Can we roll out features more quickly? And often the intention is always there. The intention is
Absolutely.
like, yeah, because now that we have this new technology platform, we can add containers and new services, and everything's going to be easy
Yeah.
to add more things. And maybe we'll have, we can deploy our PR now in as a container to see how that works. So development will go faster. We'll have more features,
Mhm.
so it benefits the customer. But that's in theory. I haven't seen that actually yet, because indeed, then
No, no,
st-
no,
they,
no.
like I said, the scope increases. It's like, oh,
Yeah.
yeah, we also need Datadog because now we need centralized logging. Now we need this. Now we need that.
Yeah.
Like there's a problem that happens here. I need tracing. I need advanced
APM.
ingress gateway API to route all my traffic. Now I have endpoints. I have a V1 endpoint here, but the V2 endpoint so complicated. And
Oh,
then
and I have to
indeed,
do a
like
database migration on that schema of that database. Then it's no longer compatible with the other services, but the other services I cannot yet update. But wasn't that the thing you're trying to solve by splitting it up in services, right? No, no, you didn't. Okay, yeah. that,
and
that,
then you actually see that um, companies that try to keep it simple are actually the ones that push out the most features consistently.
that,
Um, I think that's kind of that I'm sure there are exceptions. Like I know, for
yeah.
example, Monzo in the UK, I read their architecture when they started, and they said we are going to go full-fledged on microservices. We have a big team. This is the way we're going to do it.
Exactly. Big
Could
team.
work.
Yeah.
Big team, yeah, could work. They also had lots of funding.
Hmm.
Um, they also had a lot of problems, though, like that they were the first one to experience with certain technologies, cloud native technologies that nobody experienced because they're not at that scale, not at that level. And then there was some downtime involved because of that. Well, but if this is so beneficial for them, it can actually work for them indeed. But is everyone
Absolutely.
on this level of like a big UK bank? Not that big, but like okay, they have a
Yeah,
team of
it's an
super smart
online bank,
people,
so it's super
it's
important
yeah.
that, yeah, exactly. It's not like that you can
Not
go
everyone's
to
like
their
that.
branch. Exactly. Yeah, yeah, yeah.
Yeah, but not every company is like that. Not everyone is immediately at that scale. I
No,
mean, they
no, no,
could
no.
go there eventually, but initially, if you just want to bring out features and you just want to have like
Hmm.
yeah, a simple application, And I think the reason why we keep on repeating that is because we just saw so many companies, and you look at the application, it's like, this is something simple. This should be just a simple server. And then you
Yeah,
look at the architecture, and it's like, why are you using AWS CDK to provision 20 services, 30 lambdas?
yeah,
And then it
exactly.
gets super complicated, and stuff stops working, and they need to hire, they need to move from their development team people to operations to maintain it, and then external consultants to have a look at it. External consultants say, maybe this is not the way to do it.
Yeah, yeah, but
uh,
we've invested so much time already into it. We're just going
exactly.
forward with it, but
That's the
just
that's that's the
digging the
that's the
hole
problem.
deeper.
That's digging the hole. Like, now that you have something that doesn't work, then trying to reverse course is so difficult.
Yeah,
Trying to go back to a simpler architecture is so difficult. And then, yeah, then that's the point. That's actually the point where you have a company or a startup that's just spent so much in technology to keep their application running. I
yeah,
think um, that's where companies, that's why the Amazon bill or their cloud bill in general just goes up like crazy,
yeah,
and that they cannot keep it like at a reasonable amount per month that they have to pay. It just goes completely out of control.
yeah,
And then they
exactly.
say cloud's expensive.
Yeah, exactly. Like a good thing that I saw a lot of people do is look at the infrastructure cost per client, per paying client, basically that they have, and that was an interesting
That's a great
benchmark
metric.
because it can help you make certain decisions, and there are always maybe better ways on doing it, or in the long run, in hindsight, if you look back, maybe we should have done X, Y, Z, or whatever. But like it would have been so expensive back then that it wouldn't make much sense. And we've seen that a couple of times that some of those decisions, like like you said, a huge cloud bill. But if you then can put that money that you will be needing to pay for the cloud, be for cloud engineering team, DevOps team, whatever, just put it towards a product. Like that's the end where the client is paying for. Of course, reliability is super important and stuff like that. But there are ways around that, and one monolith doesn't like one monolith of 16 gigabytes of RAM, for example, and you split it into four, doesn't mean you have four services of 4 gigabytes running. Like this sometimes then you have four services of 16 gigabytes running, just overhead, whatever more. And then like it all adds up in the end. And then it becomes, oh, we have to split the data. You can't share the same database. One RDS becomes five RDS, stuff like that. And then it all adds up in the end. And then, why is
But
this so expensive?
the reason why this adds up is because once you say we're gonna make a second service or a second database, is also like, oh, but there's multiple availability zones. You still need to have redundancy, so you should run at least two of them. But there's also another there's a staging account or a QA account, or
Yeah,
suddenly it's not only that you multiply by two. Well, you have other environments where you also have to multiply by two, and then especially RDS. Well, the replication is expensive, memory is expensive, like just
which
these
all makes
instances
sense,
can
but
can can get expensive. So like every every vCPU, every gig of memory, it just adds up, like you say, and then at the end you just get this massive bill, and you wonder, like, indeed, when you calculate it back to cost per user, cost per event, like, why is the cost per event or per user so high? And it's often because of these decisions that you made very early on, to make a super complex architecture because you think that's what you need to run this app. And indeed, let's be fair, like most applications are completely not complicated, right? Best example is Twitter, right? Twitter shouldn't be that complicated,
no.
and that's why so many people got fired, because you should be able to do the same with a much smaller team. And then if you look at, okay, this is super controversial, um, but the same is often valid in other companies where you should be able to sustain or to be able to develop and run an application with a very small team if you don't go overboard with all the technologies and possibilities that there are, and you just kind of keep it simple. And then going back to where we started with, it comes from Amazon and other companies that said you should run microservices. When Jeff Bezos was still at Amazon, one of the sentences
Hmm.
that was repeated over and over and over again was keep it simple. Keep it
Yeah.
simple. Because they were so focused on the cost to keep the cost low. If you keep it simple, you keep the cost low. So the question in designing and in the architecture of an application should be, how can we keep it more simple? How can we keep it as easiest way as possible? Because if you keep it easy, if you keep it simple, it will translate in a low bill, infrastructure bill as well.
Yeah.
And it's so difficult because the reason why it's so difficult is because there's so many services, so many products that Amazon and Google Cloud and Azure has. It's like, uh, okay, do you want you want compute? Here's 20 ways to do compute. You want database? Here's 20 different databases you can use.
Yeah.
Do you want relational database? But maybe you also want full text search, Elasticsearch. Maybe you
Yeah.
want a bit of a MongoDB, a bit of S3. By the way, we can now do also generative AI. Don't you want to do some generative AI? Even though maybe your application could just do very simple models, open source models, but now we have this generative AI that we could use instead of a simple regression model or something. So all this complexity, and then it all is super complicated to manage it, to maintain it, to add a feature, um, and to keep it running. Like if you increase the complexity, and you say we are using microservices so that we can have better reliability, higher uptime. It's often more difficult, but because it's so complex, not everyone understands anymore what has a dependency on what, and then in the end you have less availability. Like a great example in infrastructure is when you use two availability zones. Okay, you have two availability zones to deal with. Um, but then sometimes people think like, but we have three availability zones available to us. So why don't we use three? Isn't that better than using two? And then sometimes you can get in a situation where, well, now there's three availability zones that can fail. So there's maybe a higher chance now that one will fail because now you have three and not two. And
Yeah.
what happens if one fails? Can the application recover? Do you have issues? Do you need to test that? Okay, and then some engineers don't test it, and then one availability zone goes down, and then something happens, like the app is down or whatever. So things that look straightforward are actually not always uh, helping you in achieving your goals.
Exactly. Not all things are just boxes in a Visio diagram. And like, oh, just more boxes and then like everything will be simpler. No, that's absolutely true.
But like I had another meeting beginning of this week, and the person told me, um, I have a very easy architecture. We just use Kubernetes.
Yeah.
And
Yeah,
I'm like,
exactly.
oh, not really simple then. If you already have a Kubernetes cluster running, and then I said, then I also have Grafana on there, and then services, and then I have multiple nodes, and
Yeah.
then we can scale. That's not easy. That's already complicated. Like,
No, exactly.
uh, if you have an architecture diagram with, like you say, with not a lot of boxes, that's actually often better.
Yeah.
Um,
Yeah, you don't need to force it to have less boxes, but if
well,
it's
no,
not
no, 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 no. But
necessary,
it's like you should question every box that you have on the architecture
yeah.
diagram. Do we really need this? And also, what I find interesting is that, let's say, Kinesis streams as an example. If you onboard a new customer, do you need a new Kinesis stream? If you
Mhm.
onboard a new customer, do you need a new S3 bucket?
Oh yeah,
Like,
yeah, like
if
yeah,
if if something in the business logic changes, do you need to make architecture changes on the infrastructure?
yeah.
And this I find like is such a no-go. Like you shouldn't be adding
No,
new technology,
infrastructure
new
changes.
products, new
Yeah,
infrastructure changes, just to accommodate more customers. Like your app
yeah,
should be able to work with that. Like that, I just mean by that is that what I mean by that is just that you should scale when you are at the limits of a service and when you need to scale, not
Absolutely.
just to accommodate another client. Because then indeed also your bill goes up because the more customers you have, then it goes up linearly, your cost. Whereas the more customers you have, it should not go up linearly. You should be able to spread the cost of more users
Yeah,
over your architecture that you have,
yeah,
infrastructure.
absolutely. That makes total sense. That makes total sense. But it's like sometimes I kind of understand sometimes where it comes from, but that's more in most cases more like the lack of understanding and experience in managing infrastructure. Like you said, oh, it's just for example, oh, it's just an S3 bucket, but it's not just an S3 bucket. It's like if you have to do it for all your clients, it means that you have to have people doing that, maintaining that, all that stuff. And yeah, it doesn't make any sense to do it. Why
I,
it can be fixed with a prefix, for example, something like that.
I also think when it becomes clear that it is a lot of work is only when you start doing the audit work
Hmm.
for SOC 2 or for ISO. And
Yeah.
it's like, hey, now you have, let's say, 100 Kinesis streams or 100 S3 buckets, but are they all only accepting encrypted traffic? Or is the data encrypted at rest? What are the access rules on every bucket? And what are the access rules for every role or user that can access a bucket? Can certain services access only those buckets, or can they access all buckets?
Yeah.
Um, are buckets not publicly available? And it's like so many checkboxes that you now have to check for every single bucket, and that's when it just it's just too overwhelming at that point. It's like then you think, oh, why did we do it like that?
Yeah.
Then it's too late.
Just not needed. Yeah, exactly. The consolidating part is gone by then.
Yeah, and actually that's such a good point that you didn't mention yet. So if you are in doubt, should you start with microservices or with monolith? What is the easiest? Consolidate after you have microservices, or take your monolith and then say, I will cut it in pieces and then deploy it like that. And actually, it's so much easier to take your monolith and cut it in pieces than the other way around.
Yeah.
So there is definitely it's a valid reason to start with a monolith. And then even if you made a wrong decision because you should have microservices, it's
Hmm.
easy to change,
Yeah, exactly.
but not
Like
but not the other way around.
you see the hotspots in the application quite fast whenever you start to get some more traffic and you see like, oh, those services are being visited most or whatever, and you can still pull them out the application. They're already developed, right? Like, and you replace them with API endpoints and like stuff like that. It's not that crazy because like you already have yeah, a map with the hotspots of the application, and then it's way more easier than to guesstimate like which part of this application is going to be used a lot or is going to need scaling, for example. And then yeah, it's just yeah, it's I have the same experience with that, but I've seen in the past that it's not that it's all easy and just copy paste and start a new project and be done with it, but it's a lot easier than the other way around because sometimes in the beginning you can make mistakes, and then some services are services that don't need to be microservices but could be consolidated into one service. But in the meanwhile, you have all this infrastructure, all this engineering time involved in deploying, developing, maintaining this code base to then just merge it again, and then all those databases, separate data structure. Like, yeah, it's easy, much easier than to just take it apart.
And also, what is the reason to run microservices? Why did Amazon, for example, say now we need to run microservices?
Mhm.
It was also I think the main reason was to scale developers. Like, how many developers can you have on one team? What is
Yeah,
the most efficient amount to have?
true.
What amount should I have on one team? And then they had like, what is the one or two pizza teams,
Yeah.
the self-contained teams, and that's where it actually comes from. So you so a simple question could be, do I have more than 10 or 15 developers on my project already?
Yeah.
If yes, then you might be indeed in the zone where you could think about splitting certain parts of your application. But most companies, if you just like you're a startup or you're just starting out, okay, how many developers are there in these companies the first 1-2 years? 10, 15 indeed. So, I mean, not more than
Exactly.
10, 15 often, right? So, because then, I mean, you don't even add like the front end people, right? UI, data science, that's still all separate, right?
Yeah,
Um,
exactly.
it is just like who's touching this the backend? Who is like this Java developer or this Golang developer that writes all this business logic? So if you have, let's say you have 10 people, well, 10 people can easily work on one backend. There's no reason to split it out. It's only indeed when you
Definitely.
have like, let's say that you have three teams of 15 people, maybe it can indeed be interesting that they have their own manager. Now you have to communicate. What is the communication between the teams? Could be indeed contracts API, and then you have three services, one for each team to maintain. And then
Yeah.
often you have much clearer borders on what you can touch and what not. Like one team is responsible for this business logic, this domain, another team is responsible for that. But if it's just like the 10 people within one team that have to touch everything,
Yeah.
that should be you should be able to solve it with just one service, one Git
Uh,
repository. And
Absolutely.
then you just do the PRs and then you just merge and you fix the conflicts and you deploy often. Like all the agile DevOps, the methodologies, they're still valid, right? Um,
Absolutely. Absolutely. Um,
and that 12 factor app is also like 12 factor app is also something
oh
I
yeah,
find
yeah,
find great. Yeah.
yeah.
Because then
Absolutely.
we even what we have seen is that some of the companies they do microservices, but they don't split out the workers.
Yeah, 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 yeah. That, yeah,
And if you look
exactly.
at the 12 factor app, the first thing that you should split out is the worker,
Yep.
because that's asynchronous. So I mean, if you have to scale the worker independently from the main application, that's something that makes sense. That's not really microservices you're not splitting by domain. You're just splitting like, okay, like I
Yeah,
need to be able
exactly.
to
Because
run my kind of asynchronous jobs, which can still be the
yeah,
same application, right?
exactly. It
It's
can
just the
still be
same
the same code
application.
base. Yeah,
Yeah, same code base.
a
You're
different
just running
startup command.
things. Yeah,
Kind of like yeah,
yeah. Um, and yeah, the 12 factor app is so old already. But when it kind of came out with Heroku, I just like that. I find really a great recipe.
yeah.
What you can follow to write good applications.
It will already get you quite far. Like
Yeah,
if
yeah.
you have start
If you
having
just follow that,
issues after
yeah,
the 12 factor app and you need to start migrating to a like microservice or whatever, your company is doing very well.
yeah,
Like
exactly. Like just keep it simple until you have the
yeah.
traction, until you have the all the users, and then you need to scale. Then it becomes a scaling question. Like
Mhm.
now we need to scale. Now we have 1,000 or 10,000 users, concurrent users on our application. Now we need to change our application in a way to accommodate for that,
Yeah,
and
exactly.
not we don't have any users yet. We still don't
Sure.
split it out because we are doing it for us. No,
Uh,
I think that's a
Absolutely.
bad starting point.
And those are also like super interesting like projects to do actually. Kind of on another topic, but nevertheless, that's really something I really like doing to dig in and see how you can help that. Like we've worked with big companies before where like yeah, we obviously can't mention the names, but like the those but when like scaling really becomes an issue, like really that's something interesting to have a look at. But that's my
Yeah, and
personal preference.
often it's the solution is often not really in the infrastructure space that much. You just need more compute, more memory.
Yeah,
Like, but there's also often like how did you solve in the code a certain problem? Um, is this the most efficient way to handle it? Maybe not. That needs to be rewritten,
yeah,
maybe in a different language, not always, but maybe just in a different way. So
not in the beginning.
not not everything, even though we are in cloud and DevOps and
Yeah,
we do this every day, not everything is an infrastructure problem. Actually, a lot nowadays everything is actually very easy because you can always there's always more capacity.
yeah,
If you
yeah. Don't have
and that's
to go
you
to a
don't have to
rack
optimize that
and
much
buy a
anymore.
new
Yeah.
server or whatever. Yeah, true, true.
Yeah. Like you need to optimize once it gets out of hand. But if you say tomorrow I have my backend and my database, and tomorrow I go from 1 to 10,000 users,
Hmm.
There the chance is very likely very high that you just go to your RDS, you say 32 CPUs, so much memory,
Yeah.
scale now. Five
Take my
minutes later,
money, give me a big
yeah, take my
machine.
money. And
It'll
now
still work.
and now it works. And then that often actually happens where we just say, oh, now we need to change it into an instance 4 or 8 times bigger, and then you have a time to optimize,
Yeah, exactly, exactly.
to
Obviously,
fix
the
issues.
clock starts ticking then in that sense if you want to keep it simple and at a low cost point or most efficient cost point at least, because that's not always the same, obviously. But yeah, something I wanted to mention before that as well. Uh, I don't know who said it on it was on Reddit. Somebody said like the because I wanted to give credits, but I don't know who it was anymore. But when at which point you need to change, like from if it takes longer than 1 month for a developer to get onboarded and start contributing,
Oh yeah,
that
yeah.
if they can't find their way in how to start contributing in less than 1 month, yeah, then it kind of makes sense to maybe start splitting up your application a bit. But then obviously the team, like the application will be so big that you at some point will have to do it. But that was something I read a while ago. That was something
I find it interesting because indeed, when you sometimes join a company, or when we get involved as consultants
yeah,
in a company that is already years into like developing, maintaining, running an application, there is this and there's that technology and this technology. Now, oh, by the way, here's some more. Oh, wait, here's another cloud account, and here's that. It's like,
and here's
whoa.
another box on the diagram that we forgot to mention because it doesn't really exist, but it does exist. We didn't update, yeah, all that stuff. Yeah, uh, that
The, the,
makes
the,
our job interesting, right?
in the 12 factor app, they also talk about how everything degrades over time. And that's true. I mean, the more infrastructure components you have, the more libraries you have. Um, Everything that you have that you add to your app and to your infrastructure, you have to kind of maintain that. So let's say you are on the
In
cloud.
best case, yeah.
You use RDS, which is managed. But 5 years from now, your database version is going to be end of life, and you have to upgrade because Amazon will
Yeah.
also say like, now we are not supporting it anymore. Your library, let's say that you this is always a problem. Like you have an application, you need to do something very simple. I don't know, generate a random number. But there's a library available that can generate a random number for me. It has like 1 million lines of code and it does other stuff, but I will just use that library. Now it's easy to write my random number generator instead of like these 5 lines that I could have used to write it myself, but it's better to use a
Yeah.
library. But then these libraries, are they maintained? Who's maintaining them? Will they be maintained in 5 years? And then over the years, and I see this a lot in like Node.js projects. I mean, don't want to say Node.js is bad, but you package a JSON. There's so many security vulnerabilities in there. And then you use,
Yeah.
for example, Angular or something, and then you have to wait for Angular to update before you can fix some security issues. So the bigger everything is, the more scope that you have over time, over the years, you're gonna have more work with that. Not only security updates, because some of these libraries get deprecated,
Yeah.
like nobody's working on them anymore. There's something new. Even in AWS, well, AWS doesn't really deprecate that much, but like still like in Azure, some things get
Yeah.
deprecated. Like you use some product and then they stop using the product, or you should migrate to something new, something better. So the more of these technologies that you use over time, in the long term, there's definitely more work involved. Maybe not the first year. The first year you can get away with it, but then kind of starts like the project that we have that we started in 2015. Yeah, some of these libraries, they just don't exist anymore, and then you
Nope.
need to find something new, or some of these technologies that you are using um, for deployment, or like, yeah, on the operation side there's something better, you need to migrate. There's no security updates or even in Kubernetes is like the best example for that, right? Because every 6 months there's every quarter there's something better that you should upgrade to, and then in a couple of years it's all end of life. And I think that's the what I find interesting is that if you can ask yourself the question, the application that I'm designing, if I don't want to have too much work with it, it still should work kind of in 5 years. How should I design it? What should I use? And then maybe it's not always a good idea to then use all these libraries and these dependencies um, of technologies that might not be there in 5 years.
Nope,
Like
exactly.
let's say you use Kafka because you want to use Kafka, but this specific version of Kafka, how many times will you have to update it in the next, let's say within the next 5 years? And then our code changes necessary within those 5 years
Yeah.
because the version that you are now on is not supported anymore. So this is what I also like to think about often is like keep it simple. Make sure that you don't have too many dependencies on infrastructure in the code. Do you need 100 different pipelines? Can we not keep everything like I only need one of each kind of,
Yeah,
or
absolutely.
just a couple, and not like um, I don't need 100 S3 buckets. I don't need 100 pipelines. I don't need 100 Git repositories because if you have microservices, you could have 100 microservices because it's microservices. It's supposed to be small, you know? And then
Yep.
every new service also means, okay, it could be a new programming language, it could be the same programming language, but let's say you have 5 services and you now have to, there's now a dependency that you use in all those 5 services that you now have to patch. Well, that means you have to do it 5 times. And I think that's also the problem of not being able to keep it simple means that you have to do something multiple times or certain technologies are used multiple times and it just becomes a time drain over time.
Yeah. And time drains means a lot of money as
A
well.
lot of money. Yeah.
That just goes down the drain for nothing. That nobody benefits from. Um, awesome.
Tell me a customer that asked, what programming language are you using on Netflix? Because that's actually what matters to me.
No, no, exactly. Nobody. No,
Like
like
nobody
in
asked, right? This should all be kind of decided for if you like what is the mission of a company? Okay, we need to launch this app, we need to develop features. Okay, so we need to align us to deliver features
yeah.
and not something else. That should be the first um like the first thing
The main goal.
that you
Yeah.
need to think of, the main goal. Yeah, that should be the goal of everyone, and then sometimes is not always the case.
No, definitely not. No, all right. Obviously, I think I'm quite sure that we didn't discuss everything already that we wanted to discuss, but there are always more episodes where we can talk about this as well. So I think it's best that we might wrap up here because we're already talking
Yeah,
for quite
I
some
think so
time. It
as well.
goes
Yeah,
fast always, so that's
yeah, we
good.
can talk a lot about microservices and monoliths
It
or bad
probably will come.
architectures or
Yeah, exactly, exactly.
often comes back. I'm sure that like once we start talking, we always go back to like why did someone do this? Why? And then
Exactly. Yeah.
kind of have these discussions like every single week. Not, I wouldn't say every single day, but every single week there's a discussion like, yeah, are you sure you don't want to keep it simple? Are you sure you don't
Mhm.
want to keep it simple? You know, you really need Kubernetes. You really need
Yeah.
insert X fancy technology here.
Yeah, you don't have funding yet and still want to build out a product that looks like Netflix, but with the capacity of one developer. Okay, nice. Yeah, stuff like that. No, makes total sense. Edward, always
Yeah,
nice talking to you. We'll see each
yeah.
other soon in the next episode. Take
All
care.
right. See ya. Bye
Bye
bye.
bye.